So, hello everyone. Today in this video, we are going to understand the concept of silicon and germanium semiconductors. Why we are studying semiconductors? What is semiconductor? So yeah, in the series of the study of electronics, we have studied all the series of lectures behind it. So go for it if you haven't watched for your better understanding of this lecture. So in a quick revision, I'll tell you, semiconductor is a type of material that we have studied. So there are three types of materials: conductors, semiconductors, and insulators. And on which basis we have given these three types is the band gap energy. And from where the band gap energy is coming is from the electrons and the orbit. Okay, and for that we have studied the atomic structure wherein we have electrons, protons, and neutrons. So if you haven't watched, go and watch. So yeah, we are studying semiconductors, and in the semiconductor, the silicon and germanium, we are going to see the structure in detail. So first one, we'll see silicon. Okay, silicon is present in most rocks and sand. So before even we get started, let me tell you, all the semiconductor devices in the electronics are made up of the semiconductors. And in the semiconductor, widely used semiconductor is silicon. So you should know from where it is coming. So yeah, the sand and rocks, okay, these are the raw forms of the silicons, and it's present in the form of silicon dioxide. Okay, so this dioxide then chemically is reduced to obtain the pure silicon. Okay, so it is not available in the form of pure, we have to get it pure. And the pure silicon, there's one terminology in the physics or science, you can say, it's called intrinsic semiconductor. Okay, so what is intrinsic semiconductor? What is extrinsic semiconductor? What are their significance? That we are going to study in the next lecture, which is again one of the important topic of the series. So pure silicon obtained is 100% pure and is used as a semiconductor. So we all know the atomic number of silicon is 14, right? I have shown here the atomic structure of silicon. Si is the atomic symbol of this silicon. And now see, one, two, three orbits are there. Why three orbits? Because silicon is having 14 atomic number. So let's just go on divide. We know the formula 2n square. The first shell has a maximum number of electrons is 2. Second number has a maximum number of electrons is 2n square, that is n is equals to 2. 2 raised to 2 is 4 into 2 is 8. Yeah, so 8 number of electrons. So 8 plus 2 is 10, but the atomic number is 14. So remaining 4 electrons will be in the outermost shells. Outermost shell is known as the valence shell, and the electrons on the outermost shells are known as the valence electrons. So yeah, the electronic configuration is simple: 2, 8, and 4. So whenever there is 4, we call it tetra. Tetra. So yeah, valent means valence electrons, tetra means 4. So yeah, we can say that the silicon is a tetravalent element. Okay, there's one terminology is called tetravalent, having the 4 valence electron. So this is the individual atomic structure, but never any atom occurs in a nature as an individual. It occurs in a crystal compound. So yeah, what is there? What is in there in the crystalline form? So what is covalent bond? We are going to study. See here, these all are silicon atoms. Okay, these all are silicon atoms. Every silicon atom is surrounded by 4 dots. Okay, these dots are nothing but the valence electrons. Valence electrons are the only electrons those are taking part into the reaction, and that's why 2 and 8, the first shell and second shell, electrons are not shown in the figure. Only the participating electrons are shown in figure. So every silicon is surrounded by 4 valence electron. Every silicon is surrounded by 4 valence electron. Now what happens? To make the silicon stable, it needs 8 electrons in the outermost shell. It needs 8 number of electrons. It has already 4. It needs more 4. So see, the first, if I consider the central silicon atom, it is surrounded by the 4 valence electrons, and it is sharing 4 valence electrons of the neighboring atom. One is from right, one is from left, one is from above, and one is from down. Now this silicon atom is having 8 number of electrons, but are these 8 electrons completely of Si, that completely of this one? No, it is shared by another atom as well. For example, if you take example of this rightmost silicon, it is again surrounded by 1, 2, 3, 4, 5, 6, 7, 8. So that means every electron is being shared with the neighboring atom. So this bond is nothing but covalent bond. Okay, this bond is covalent bond, and the structure is formed is called as a crystalline structure. Okay, it's called the crystalline structure, wherein every silicon atom is sharing their 4 valence electron with the neighboring atom, so as to they satisfy the condition of having the 8 electrons in their shell to make them stable in nature, right? So this was about silicon. We'll see about the germanium. The second most widely used semiconductor is germanium. We'll see is valued for easy purification and crystallization. Why the germanium is used and why the silicon were used? Because of their electrical property, and plus they are available abundant form in the nature. Okay, and it's easy for purification to remove the dirt part to make it pure, 100% pure, and make it more crystalline. So again, it is recovered from coal ash and zinc smelter dust. Okay, it's one of the byproduct of zinc smelting process. And coal ash we recover this germanium, and it's obtained in the form of dioxide powder as it of silicon. What is the germanium? Atomic number is 32, that we already know. This is the atomic symbol Ge, and 32. So what should be the electronic configuration? As it of silicon 2 8, right? Third orbit is having maximum number of electron holding capacity is 18 as per the rule 2n square, where n is equals to 3. So 3 raised to 2 is 9, 9 into 2 is 18. So 2 plus 8 is 10, 10 plus 18 plus 4, right? 4 are the maximum valence electrons that can lie on the outermost orbit. So this is the electron configuration. So same as that of silicon, it is also having the 4 valence electron. So we can say it's a tetravalent element, and also it is having the same crystalline structure as that of silicon. Why is the same? Because we are considering valence electrons while making the crystalline structure. There were 4 valence electron in silicon, and there were 4 valence electron in germanium. So yeah, the crystalline structure of both are same. Now we'll just discuss the energy band description. Okay, we are discussing semiconductor on the basis of energy band. Now we are discussing individual silicon band energy and germanium band energy. Now when calculated, it says that silicon band gap energy is 1.1 electron volt and germanium band gap energy is 0.67 volt. Now tell me, if silicon is having 4 valence electrons, germanium is also 4 valence electron, both the crystalline structure is same. Now how the band gap energy is different? How the band gap energy is different? Yeah. So band gap energy is different because the 4 valence electron of germanium present in the fourth orbit, while the 4 valence electron in silicon present in the third orbit. That is the difference. And we have studied in the atomic structure that as the number of electron orbit is goes away from the nucleus, the attraction power with the nucleus goes on reducing. Okay. So yeah, as we are moving away from the nucleus, the electron becomes more prone to become in a conductive band. Okay, so that's why germanium band gap energy is less than that of silicon. I hope you got the explanation about it. This is the forbidden gap. That's what we are talking about, the silicon band gap and germanium band gap. Okay, and now we are saying valence electrons are easily moved to the conduction band. Okay, why we are considering semiconductor? Because in conductor the gap is overlapping. In insulator this gap is so much. In the semiconductor this gap is appropriate. So here valence electron can move into the conduction band when after getting some amount of energy. So yeah, semiconductors are neither good conductors nor insulators. Intermediate electrical conductivity is there between conductors and insulators. And how can we enhance the conductivity of the semiconductor? By making one process is called doping. And what is that doping? And by doping we are making n type and p type, that we'll see next lecture. So yes, this was all about your semiconductor, silicon and germanium. Thank you.